Hi friends, welcome back to Masters of Chemistry. So today I am going to start a new video lecture series on nuclear chemistry and radioactive chemistry. So today in this particular video we are going to discuss the basic introduction to nuclear chemistry, radioactivity, what is meant by the alpha, beta and gamma radiation, their interaction and comparison of alpha, beta and gamma radiation and their properties. So first we are going to discuss the introduction to nuclear chemistry. So first, the phenomenon of nuclear chemistry was introduced by Henry Becquerel. He is known as the father of nuclear chemistry. So in the year of 1896, when he is performing an experiment over a specific element known as uranium, during his experiment, he observed that the uranium giving out some of the radiation. When this radiation incident over a photographic plate which is wrapped inside a thick black paper, he found that these radiation are making changes some of the photographic plates, such as they are highly penetrating, ionizing the gases and causes scintillation on the fluorescent screen. The scintillation means it producing some kind of spark over a fluorescent screen. Now, from this study, there are two scientists, Marie Curie and Pierre Curie, conducted a experiment on the uranium, and they successfully extract a new element from the core of this uranium, which is million times of more radioactive than the this uranium. This element is known as radium, and because of their invention, they got a Nobel Prize of in chemistry because of this invention of radium. Next one is the radioactivity. The radioactivity means it is the spontaneous emission of radiations from the radioactive substance that we called as radioactivity, and the substance which emit the radiation that we known as radioactive substance. So some of the example of such radioactive substances are uranium, polonium, radium, radon and thorium. So these are the some specific element. Apart from that, there are number of elements are present in the nature which are radioactive in nature. So radioactivity again classified into two types. One is natural radioactivity, another one is the artificial radioactivity. So we will discuss one by one in detail. Natural radioactivity. If a substance emits the radiation by itself, then we called as natural radioactivity, and the substance is naturally radioactive in nature. So for some of the example of natural radioactive substance are the heavier elements present in the periodic table are natural radioactive in nature. Next one is the artificial radioactivity, which is also called as induced radioactivity. If a substance does not possess radioactivity but start to emit the radiation on exposure of rays from a natural radioactive substance, then such type of process we called as artificial or induced radioactivity. That means if a substance not able to emit the radiation continuously, but on the exposure of any natural substances radiation, it start to emit the radiation continuously. So this phenomena we called as induced radioactivity. So radioactive substance having a some kind of special properties. So there are three kind of special properties which can be given. So first one is the radiations are highly penetrating. They affect the photographic plate, ionizes the gases, causes scintillation on fluorescent screen, develop the heat and produce the chemical changes. Second specific properties of radioactive radiations are as radiation gives out, new elements are formed in an irreversible process, and these new elements themselves being usually radioactive in nature. The emission of radiation is spontaneous and it does not affected by external agents. So the any radiation coming out from the radioactive substance are spontaneous. That means there is no external body required or external agent required to produce that radiation. It will become spontaneously and continuously. Next one is the nature of radioactive radiation. So Rutherford and his co-workers discovered the nature of radioactive radiation and they demonstrate the experiment. So this experiment consists of a lead block. So in the given diagram we can observe that there are two kind of lead blocks are present. In this lead block, small drill hole is made, and this small opening the radioactive substance is placed, which is shown by a small red dot. When this radioactive substance is placed inside the electric field, we can see in the left side, when it is placed inside the electric field, the radiation which are coming out from this small opening, so some of the radiation are bending towards the negative plate, and some of the radiation are passing through the positive plate. So the radiation which are passing through the negative plate, that we called as alpha radiation or alpha particle, and because they are positively in charged, and some of the radiation which are deflecting towards the negative plate, that we called as beta particles, and the beta particles are negatively charged, that's why they are deflecting towards the positive plate. And third one, the radiation which are remain undeflected, that we called as gamma particle or gamma radiation, and these radiation are neutral in nature. The similar observation will be observed when the radioactive substance or element placed inside the magnetic field. So this is about the nature of this radioactive substances. So in the next video we will discuss about the some of the properties of this alpha particle, beta and gamma particle and radiations, and their comparison.